Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. A molecule possesses a plane of symmetry, sigma, if there is a mirror plane that bisects it into two mirror image halves, and a center of symmetry, inversion center, I, if every atom has an equivalent atom at an equal distance on the opposite side through a central point. A molecule that is achiral can have both elements of symmetry simultaneously. Analysis of each option. Option A1, 2 desubstituted cyclobutane with methyl, wedge, up, at C1 and Cl, dash, down, at C2. These are different substituents on adjacent carbons with opposite configurations. This molecule is chiral, no plane of symmetry, no center of symmetry. Option B1, 2 dichlorocyclobutane, trans configuration, C1 has Cl on dash and C3 has Cl on wedge, or trans 1, 2. For trans 1, 2 dichlorocyclobutane, the two Cl groups are on opposite faces. This molecule has a center of symmetry. The two Cl atoms are related by inversion through the ring center, but the plane of symmetry analysis, a plane through C1 and C3, or C2 and C4, does not make it symmetric because the Cl groups are on opposite faces. Actually, trans 1, 2 dichlorocyclobutane has a center of inversion but no plane of symmetry. It is a chiral molecule with Ci symmetry only. Option C1, 3 dimethylcyclobutane with both CH3 groups on wedge, CIS 1, 3 dimethylcyclobutane. Both methyls point up on the same face. This molecule has a plane of symmetry. The plane bisecting the ring through C1 and C3 is a mirror plane, but does not have a center of symmetry because there is no inversion center relating the two CH3 groups. They are both up, so inversion would place them both down, which is the same molecule weight. Actually, CIS 1, 3 does have a plane of symmetry through C2 and C4 axis. CIS 1, 3 dimethylcyclobutane has a plane of symmetry but no center of symmetry. Option D1, 3 dimethylcyclobutane with CH3 on wedge at top right carbon, C1, and CH3 on dash at bottom left carbon, C3. This is trans 1, 3 dimethylcyclobutane. In this molecule, C1 has CH3 up and C3 has CH3 down. A plane of symmetry exists. The plane containing C2 and C4, perpendicular to the C1, C3 axis, bisecting the ring, maps C1 onto C3 and reflects the up, CH3 to a down position matching C3, so this is a plane of symmetry. Additionally, the center of the ring serves as a center of symmetry. Inverting through the center maps C1, CH3 up, to C3, CH3 down, and vice versa, satisfying the inversion center requirement. Thus trans 1, 3 dimethylcyclobutane possesses both a plane of symmetry and a center of symmetry, making it the correct answer. Therefore, the correct answer is D. Therefore, the correct answer is option D.